The recording has started. So, good evening, ladies and gentlemen, and thanks for joining me tonight in attending this evening seminar entitled Nepal EEFIT Return Mission, Shared Knowledge on Earthquake Recovery and Reconstruction. To give you a bit of background, the devastating magnitude 7.8 earthquake, which struck Gorkha in Nepal on 25th of April 2015, was the deadliest earthquake in the seismically active region in 18 years, toppling multi-story buildings in Kathmandu, the capital, and creating landslides and avalanches in the Himalaya mountains. Nearly 9,000 people died and more than 22,000 suffered injuries. It is important to remind you that a report focusing entirely on the mission is available on the EEFIT website, which I highly invite you to check out for more information. This evening, we will have the great chance to learn the findings of the return mission instead, during which the EEFIT team will discuss the recovery, reconstruction, and the Build Back Better approach, analyzing both the physical reconstruction and the institutional framework for the disaster risk reduction. So let me introduce you the speakers. In order, we have Dr. Michael Whitworth. He's an Associate Director at AECOM and the UK Ground Engineering Technical Practice Lead in Geohazard and Risk. Michael was part of the EEFIT team to Nepal in 2015, has worked on the UK aid-funded Nepal post-earthquake reconstruction planning, and has undertaken research in Nepal on the impact of a range of hazards on critical infrastructures, including landslides and glacial lake outburst floods. Michael has led projects globally, focusing on the impact of geological hazards on a range of infrastructures and has an interest in improving the resilience of systems and reducing disaster risk. Then we have Dr. Diana Contreras, who is a lecturer in geospatial science at Cardiff University and currently the vice chair of EEFIT. Her research focuses on earthquake reconnaissance using social media and crowdsourcing platforms, learning about post-disaster phases via ludic activities and socioeconomic vulnerability assessment. She is currently visiting researcher at Newcastle University for the project Learning from Earthquake, building resilience communities through earthquake reconnaissance, response, and recovery. Then we've got Dr. Giorgia Giardina, who is an associate professor at the Delft University of Technology. She is an expert in geomonitoring and structural damage assessment. Prior to joining the Technical University of Delft, she was a lecturer at the University of Bath, a visiting professor at the NASA Jet Propulsion Laboratory, and a research associate at the University of Cambridge. Georgia's research aims at increasing urban resilience through the evaluation of buildings and infrastructure vulnerability. Then we've got Fateme Forugna, who is a PhD student at the Civil Engineering and Geoscience Faculty of the Delft University of Technology. She obtained her master from Tosi University of Technology, Tehran. Her research interests include exploiting remote sensing data for natural hazard monitoring and geospatial analysis. She specifically focuses on seismic application in estimating induced ground deformation and damage to structures after an earthquake, using remote sensing techniques in integration with structural engineering. Then we've got Dr. Valentina Macchiarulo, who is a research associate at the Delft University of Technology. She completed a PhD at the University of Bath, UK, spending part of her doctoral training as visiting researcher at the Jet Propulsion Laboratory of NASA. Valentina's research focuses on the use of remote sensing techniques within civil engineering applications. Then we have Dr. Rohit Kumari Adhikar. He's a research fellow within the UNESCO chair in disaster risk reduction and resilience engineering at UCL. He obtained his PhD in structural earthquake engineering from UCL with a focus on the seismic vulnerability assessment and risk reduction to school infrastructures. He has worked in the Global Program for Safer Schools of the World Bank in developing practical tools and methodologies for seismic risk assessment reduction to school infrastructures. Then we've got Dr. Sean Wilkinson, who is an associate professor at the Newcastle University. He has led the EEFIT mission to Indonesia, Christchurch, and Nepal, and was the PI on EEFIT missions to study the effects of the Indian Ocean tsunami in 2004 and Sumatra earthquake in 2009. His expertise is in the performance evaluation of buildings and critical infrastructure subjected to extreme loads and how failures of this impacts on communities. In addition, he has used these experiences gained observing the impacts of earthquake to inform research on the analysis of UK infrastructure networks subjected to other hazards. And finally, we've got Dr. Paul Jacquin. He's a structural and geotechnical engineer in Queenstown from EZ, working on sustainable building projects around Otago, Southland, and wider New Zealand. In 2015, Paul was part of the New Zealand government-funded group of engineers who worked in Nepal, providing high-level engineering expertise following the earthquake. Paul is a specialist in mud brick earth construction, unreinforced masonry buildings, and unsaturated soil mechanics, and has published a number of books and papers related to earth constructions. But also let me mention that there are a number of people who are not present tonight who were not just team members, but also support members in the field, while organizing the workshop entitled From Nepal to the World, Shared Knowledge on Earthquake Recovery and Reconstruction. Now, without further ado, I leave the microphone to Michael.
Thank you very much. Thank you very much, and thank you very much for joining us on a wet evening. So I'm going to provide a little bit of the introduction to the mission, a little bit of background to the 2015 mission, and the plan for the return mission in 2022. We're going to first of all do a little bit of an introduction, a little bit of background of how things have changed in our understanding of the seismotectonics, and then I'll hand over to Diana to talk about post-disaster recovery in social media and also ludic activities, and then hand over to the team from Delft, who will talk about remote sensing and how that can support disaster management, before I hand over to Sean, Rohit and Paul to talk about building structures. And then we'll summarise a few key messages throughout that presentation. A little bit of background and a little bit of the 2015 mission. So these are just some snapshots from pointer. So these are a little snapshots. So the mission started off in 2015 visiting Chautura in the east and looking at sort of building infrastructure, and then also picked up schools, historic buildings, sort of local housing development. My specialty is in landslides, and also I see Sarah here in the background, also looking at and utilising geophysical techniques to understand geotechnical conditions. So the mission was about 10 days long, so we transferred from Chautura through Kathmandu, across to Gorkha, and then to the remote communities via helicopter in the 2015 mission. And the aim of the 2022 mission was to revisit these locations to the best of our ability to look at the recovery phase and to look at how Nepal had recovered and post the 2015 earthquake. So in the days and weeks and months we were focused on in the 2015 mission, looking at short to medium term recovery, where in the 2022 mission, we were focusing and looking at the long-term recovery, the rebuilding of infrastructure to meet future needs, but also looking at how this was feeding into future risk reduction and recovery strategies to basically prepare Nepal for future events. So just as a little bit of a background for those who aren't familiar, as Valentina said, it was a magnitude 7.5 event earthquake, occurred on the 25th. There were 2 strong aftershocks and about 9,000 casualties and about 22,000 people were injured. There was in the region of about 30,000 landslides, which killed approximately about 1,000 people of these casualties. And the economic damage was estimated as part of the post-disaster needs assessment and the post-disaster risk framework to be in the region of about £7 billion. And Nepal had an extremely ambitious target of recovering over the first 5 years. So the aim was to recover and rebuild between 2015 and 2020. So part of the mission was to look at how they'd achieved that and whether they'd achieved their stated aims of building back better. And this is the status of play, just to set the framework. So in terms of private houses, you're looking at approximately of the over 800,000 that were assessed to be damaged. You're looking about 74% is currently reconstructed. So still a huge amount of work to be done. And if you weren't aware, I meant to switch this side around, but this is where the predominant damage was undertaken. In these areas here where all the main casualties, but the damage was extremely widespread and covered 31 of the over 70 districts. So a huge impact. So then just a quick overview, and the idea is not to give you a history of the seismotectonics of the Nepal earthquake, but really to look at what has changed since 2015 and how our knowledge has improved about the seismic hazard and the seismic motion. So this is some work by Paul Burton and Co-Chan on the team, and I'm presenting on their behalf because they couldn't be here today. So this is looking at basically the research and how our understanding has changed since 2015. So one of the issues that they're looking at and where the attention is now looking at moving forward is trying to evaluate and understand the seismic hazard in more detail, looking at the magnitude and the potential magnitude of the earthquakes, looking at the zones and the seismic hazard zones and the implications for the sort of seismic hazard maps within Nepal and sort of mapping the progress of that work. What they've identified is that possibly the work and the previous work in terms of the zonation of the hazards and developing a seismic source zone is probably not the right way to go forward. It has meant that they are probably not being able to capture the range of magnitudes and the range of hazards that exist from these fault sequences. So the potential for something of magnitude 8 or greater is not currently being identified or wasn't originally identified within the original models. So subsequent work is looking at and trying to evaluate those sorts of hazards and trying to identify where we might be getting potential future impacts. So this is where potentially we could be getting a rupture area of greater 8. So what they found is that there are potentially large areas where future earthquakes may occur, and what that is leading to do is that the early seismic hazard map, which dates back to 2002, requires to be updated and moved forward. And as support for that, Nepal has started to move quite drastically forward in terms of their seismic network to support these assessments. So in 2015, there were very few accelerometers or very few instrumentation to monitor the earthquake and learn from that earthquake. And a lot of work has gone in to improve the seismic network within Nepal and increasing the number of sensors to map and evaluate the seismic hazard. So this is one of the things of the future development for Nepal to improve their understanding going forward. So without further ado, I'll hand over to Diana.
Thank you, Mike. In this presentation, we are going to see how post-disaster recovery can be assessed using social media. So I'm going to give you a brief introduction. I'm going to describe you the data that we use, how the methodology that I apply, the results that we have so far, and the conclusions. Lately, social media platforms have become a source of large amount of image and text data after earthquakes, but also during anniversaries. And from this image and text data, it's possible to extract meaningful information. However, this text data that is extracted from social media platforms is unstructured data. Then it's necessary to use natural language processing techniques such as sentiment analysis to extract that information. This technique, what it does is to classify the data according to the polarity. In case of an earthquake, there will be data that contains expression of distress, that reminds the injured and casualties, or complaints about the progress of the post-disaster recovery. But there are also posts that mention the magnitude and the depth of the earthquake, or that invites to a commemoration ceremonies in the case of post-disaster recovery. But there will be also messages of solidarity, announcement of buildings reconstructed, houses available, or lessons learned. This kind of text will be classified with a positive polarity. What happened? This technique is used mainly in customer reviews. Then the question is, why we use it for post-disaster recovery assessment? Well, because I conceive that the post-disaster recovery as a service provided by governments to the citizens, to the population affected by earthquakes, and the population have the right to express their satisfaction or dissatisfaction with the recovery process. For the case of Nepal, using these hashtags, we collect this number of tweets between the 6th of March, when I saw the first tweet regarding the anniversary of the earthquake, and the 2nd of May, 2 months. Here you can see the peak. This peak is related to any other seismic event that is not in our interest to study. From this number of tweets, 95% of them are original, the rest are retweets. And it's true that it's already 7 years after the earthquake, but I collect data for the 5th anniversary, that is in 2020. Why? Because in the project Learning from Earthquakes, we are collecting data in terms of 5 and 10 years for the disaster recovery processes. And the other point is that the government gave to the National Reconstruction Authority 5 years to complete the reconstruction. For this presentation, I analyze the data 2 hours before and 2 hours after the exact moment of the anniversary. It means the 25th April, 1156. Without counting the non-related events, we have a sample of 685. Now, how the data is classified. Every action or fact that contributes to the recovery, like in the list that you see here, is classified as positive. Again, any action or any fact that could delay the recovery is classified as negative. For the case of Nepal, the decline in remittance is particular, and data that is related to the magnitude of the debt, or data or posts that invite people to the commemoration ceremonies are classified as neutral, because it doesn't contribute, but also it doesn't delay the recovery. Yeah. Here, we have some example of tweets classified with positive, negative, and neutral polarity. You see, this tweet discuss or mention a temple that is finally restored. This tweet complains about that the recovery is still ongoing after 5 years. This tweet is only a question about the post-earthquake reconstruction conditions. And here is an example of a tweet that is not related to the event. We have a sample of 685 tweets, but I want you to notice that a tweet can contain more than one polarity, especially those who are larger. Then I show you this example that contains neutral, negative, and positive polarity. For this specific case, I did the analysis not at the tweet level, but at the sentence level to see if there is a difference and to aggregate some level of granularity to the analysis. And so far, this is the result. I mean, it's mainly negative, but followed not by far by positive and then far by neutral. Besides using sentiment analysis, I use topic analysis, which is another natural language processing technique that identifies the frequent topics addressed by the users on their tweets. This list was created based on the data that we have analyzed from the earthquakes from the anniversaries of the earthquakes in L'Aquila, in Chile, and in Haiti. Except for the COVID that is particular for the case of Nepal, because the 5th anniversary match with the time when the lockdown to stop the spreading of the COVID started. Here we can see the distribution of the topics, and the main the topic that is mainly discussed is the recovery. Here we can see. Second, the COVID, that is mainly related to the dates when the flights will be cancelled. Then the emergency response, that it's mainly done by the NGOs working on Nepal to promote their work, their actions there. And the seismic information, which honestly is more mentioning that it's already 5 years after there. Then here, I want to show you examples of topics, examples of tweets on each of the topics. So the recovery in the long term, but if you see, it's also about emergency response in the case of COVID, and it's related to also to the remittance and the emergency response, that it is one of the most retweeted tweets, and the seismic information. If you notice also, several of these tweets contain different topics, but I haven't analyzed it at sentence level. Then my conclusions are, the most of the tweets about the anniversary comes from NGOs and foreigners. The rest of the tweets talk about the situation related to COVID, try to promote tourist activities in Nepal. They discuss the Nepalese landscape, also linked to the tourist activities, politics laws, and more, I will say, more daily problems. Then, I found that there are less activity on social media than there is when there is a 10th anniversary. Based on the most retweeted tweet, I think there was maybe a lack of preparedness among population in that time. The tweet says that there is still reconstruction, but advanced is still to come, and reconstruction from over. It depends, it varies. I believe that the COVID have a high impact on the reconstruction, and it had. But it's not only COVID who impact the reconstruction in Nepal, it's also the weather. Yeah, this is what we saw on the visiting to schools. The problems in the reconstruction are more related with the limited economic resources, with the grants provided by the government, that makes that houses reconstructed are smaller than the houses that people has before. Keep the World Heritage condition of the buildings, having trained manpower, and this is common for many cases. I think also for L'Aquila, the lack of property rights. In the case of Nepal, for the rural areas, when there are no tradition to have ownership documents, then people without ownership documents doesn't have access to the grants. to reconstruct their houses. There are more progress in the houses than in the urban facilities. The government had made more emphasis in the reconstruction of schools. My opinion is that Nepal is moving from the recovery to the development phase, considering the progress in retrofitting, in the renovation of urban spaces, and the improvement in preparedness. There is no significant difference in the analysis at sentence and at tweet level. That's what I found. And most of the negative polarity is related to COVID, not really to the reconstruction. I'm going to continue discussing post-disaster practices via ludic activity. So again, I'm going to introduce you to the methodology applied. I'm going to explain how this methodology works, the results and the conclusion that we got from that workshop. Then, the initial line of this methodology is to learn about post-disaster phases. But for this workshop, I adapted to discuss about post-disaster recovery practices in Nepal. The methodology is based on some preliminary questions, a couple of fluid activities that include the discussion, and this methodology has been applied previously, of course, with changes in Colombia, Austria, Italy, Chile, and this time Nepal. Then I formulate 12 questions using an interactive presentation tool to guarantee anonymity in the answers. And with this tool, I can make answers with multiple choice, open-ended answers, or produce word clouds. Here we can see the QR code that, and through that code, people can access to the question and can answer what they see on the screen. And here we see. Now, the first activity is done with puzzles. I use 3 kinds of puzzles with different level of complexity and completeness. For the activity, this is almost complete. This is half complete. This is to be done to complete. So what is the idea of using puzzles? The puzzles. The idea is a metaphor for the reconstruction of a city. There are 3 groups and they need to make agreements or thinking a strategy into each group to complete the puzzles in the less possible time. And I enter to explain the characteristics of each post-disaster phase, considering the relief or the emergency response when the priority is to save lives, then the early recovery in which the idea is to help people to move from the dependence of humanitarian aid to arrive to the phase of development. And the recovery is considered as a phase of return to the normality. Usually areas only get arrive to this phase because the development is to improve upon what existed before the earthquake and to learn from the lessons from the earthquake. Then, after that, the idea is to allocate this set of cars and construction machinery to each post-disaster phase that is plotted in a banner. Here we see the activity, we see the discussion. This is before starting. Now, what are the results? Well, being in Nepal, of course, most of the participants have experienced an earthquake. Then, if there was, one of the questions was if there was a post-disaster recovery plan at the time of the earthquake or now. If there is one or there was one, it hasn't been socialized. And of course, most of the participants know what to do in case of an earthquake. They actually provide plausible recommendations or actions to respond to the emergency. They were very aware about the secondary effects of the earthquake, mainly landslides. They identify the post-disaster phases, but they have problems to differentiate the concept of lifelines, urban facilities, and critical infrastructure. the long-term effects mentioned by the earthquakes and long-term effects mentioned in the tweets, and usually are common for all the recovery cases. What I say. Now, the result of the activity 1 shows that the participants consider that the case of Nepal is compared with the puzzles, with the most complex puzzles. In the second activity, here we can see the distribution of the vehicles and construction machinery, and I realized that it's necessary to adapt this methodology to each particular case, and the results are different. I'm going to show you also why, because this kind of construction machinery usually in other cases are allocated to the early recovery. But in the case of Nepal, the participants insisted that should be in the emergency phase. Why? Because of the landslides. So it's necessary to remove earth, to unblock roads, and to facilitate the emergency operations, and also to unblock the roads to distribute humanitarian aid, or also to look for survivors. Also, there are some specific transport media that are not common to any other cases that should be included also in the methodology for the case of Nepal or any case in South Asia. And my conclusions is, at least for disaster phases and emergency response action are well known, so I think there has been an effort in the country to improve the preparedness of population. It's necessary to socialize. If there is a post-disaster recovery plan, it's necessary to socialize among population. It's necessary to clarify some terms. And as I said before, I was thinking that the impact of COVID-19 in the reconstruction was higher. And it's not only COVID, it's also daily things like the weather. And also I was thinking that people allocate priority to the reconstruction of temples as a symbol, and they say no, we focus on reconstruction houses. As I say, it's necessary to adapt this methodology to each case study area because results can be different. And well, vehicles and construction machines were easily associated to the post-disaster recovery with some changes according to the case of Nepal. And this is all from my side. The floor is yours.
Thank you very much. Thank you, Diana. In the next bit, we are going to look at the different, jump back from the first presentation from Diana, certain type of remote sensing. Now we are looking at different type of remote sensing, and we are going to check how specifically satellite data can be used to support the damage assessment and the reconstruction evaluation. So we have seen in the past 20 years a really big development of remote sensing techniques all over the world. So we have new different sensors that can provide very high accurate data that we can too bad. Wasn't working perfectly until now, and everyone managed successfully to do that. And I don't. Let's see. Yay! So we have a high spatial density, so we can actually collect information about a lot of points on certain areas. And we have now satellites that cover with their acquisition the entire Earth surface. Another good news is that this type of information, they are being collected regularly. So we have a possibility to keep updating them. And in previous EEFIT missions even, we have used different type of satellites, so different type of sensor, from optical sensor, which are basically, to simplify, the type of sensor that allow us to get Google Earth images, to radar sensors. And we have looked at both the primary effects of earthquake, so just the immediate consequence of the shaking in terms of damage of building and infrastructures, but also secondary effects, like, for example, the detection of landslides. In this specific case, we focus on one hand on the building evaluation, so the evaluation of the reconstruction, changes in the structure on large scale, and on radar satellites. So if we look at synthetic aperture radar satellite, basically we have a technology that exploits the relative position between satellites and the Earth to acquire information about changes in the distance between the satellites and the Earth's surface as well. And that means that we can get information about if an earthquake happens, we can detect the change that occurs together with the event. So a little bit more specifically, because we have used in this application a radar satellite to detect deformations, the idea is that we have a satellite that go around its orbit around Earth that send a radar signal. The radar signal is sent back and reflected by objects on Earth that they are reflective, like structures are really well reflected. And then the next time that the satellite finds itself on the same position along the orbit and send the same message, the same signal, and the signal is again recorded, if any change happened in between the situation on the object that was measured between time 0 and time 1, from the phase difference of the signal that has been recorded, we can detect deformation. So we can actually calculate along the line of sight of the satellite, this line that connects the satellite with Earth, we can see if there was any change and quantify it. So the accuracy right now, it's actually quite good. It's surprising that we can detect changes in terms of centimeters and millimeters. And everything is working in relative space and time. So we calculate relative changes with respect to the reference point in time, the beginning of our multiple observation that are represented here with this stack of images. And we calculate deformations relatively deformation in space because we have a reference point that we assume as stable, and we calculate everything that is happening in relation to that point. So what we get as a final result is this is just a map of London, so you should be probably more familiar even with this one, but it's only to define as an example the fact that we get information on targets. Later they are called persistent scatterers, so you know what we are talking about in the next slides as well. And for each of those targets, we get information about the development in time of a displacement, so a relative movement, which is basically time development versus settlement. Now, for this kind of targets, they have different characteristics, and we are going to exploit the different characteristics of targets to try to understand and to get some more information about structure changes. And this is what Fatema is now explaining us a little bit better in the next part of the presentation.
Thank you, Georgia. As Georgia mentioned, in the PSINSAR technique, we use a series of radar images, which makes it possible to identify two different types of targets on the ground. One group of targets is the ones which return weak and distributed signals to the sensor, like trees or vegetated areas, which we are not interested in this work. And the other group is the ones which return strong and stable signals to the sensor. And we know them as persistent scatter points or PS points, as Georgia said. A perfect example of these targets is man-made objects like buildings. As you see in this slide, buildings reflect strong and stable signals to the sensor. However, when an earthquake happens, damaged or collapsed buildings do not behave as persistent scatter points anymore. As you see in this slide, an intact building before an earthquake shows the stable reflections. However, after the earthquake, the damaged building shows weak reflections and cannot be tracked anymore. So we use exactly this information of a PS point to identify areas with the most changes, and also to track buildings after the 2015 earthquake in Kathmandu area. I mean buildings like damaged buildings, reconstructed buildings, or even new buildings. For this purpose, we did a change detection analysis to find the changes, and we did this analysis on two different scales, large scale and also at building level. But how does this change detection analysis work? As I mentioned earlier, a PS cannot remain a PS after an earthquake in case of, let's say, severe damage. So if extensive damage occurs or a collapse occurs, we will be able to see changes in the number of PS points after an earthquake for an area of interest, for example. So to go after that, let's say these areas that change in terms of number of PS points, we process two different time series of radar images before and after the earthquake to find and also, let's say, to determine PS points. But for the larger scale analysis, what we did was basically to split the entire area into 100-meter grids, and for each grid we counted the number of PS points to find the difference or the change. For example, here for this grid we see much more PS points identified with the pre-event radar images analysis compared to the post-event radar image analysis. It means that the number of PS points decreased after the earthquake, so we can expect, let's say, for example, damaged buildings for this area or this grid. The next analysis was to see changes at building level, as I mentioned earlier. For areas or, let's say, for grids with a higher level of change, we did exactly the same procedure at building level to find buildings with the most changes. For example, here you see the building footprints, and you also see the number of PS points identified with the pre and post-event radar images analysis. As you see, we can also expect here damage for this building. Why? Because the number of PS points decreased, so something happened to this building. And finally, we see the, let's say, grid-based change map result here for the entire Kathmandu area. We categorize the difference in the number of PS points into different levels of change. And as you see in the close-up pictures, there are areas with the most changes where we see red dots. Actually, there are areas with the changes that can be attributed to the building damage. Thank you for your attention. I will hand over to Valentina to explain the field investigation process.
Good evening, everyone. So the next step of this piece of work was to plan the field investigation around the results of the remote sensing analysis. So for the field investigation, we were mainly interested in two aspects. First of all, we wanted to validate the methodology previously presented by Fatemeh, and then a second point, we wanted to show how this kind of output, the output of the remote sensing analysis, could be used as a guiding tool in the field. For the field investigation, we decided to focus mainly on 3 regions of interest, which correspond to the 3 areas highlighted by the black rectangles in the slide.
And these locations were chosen as they correspond to areas for which we are able to observe large magnitude of changes, or for which we have previous knowledge of damage based on the outputs of the 2015 mission. To better guide our investigation in the field, we then decided to move from the large-scale analysis, from the output of the large-scale analysis to the results of a building-level analysis. This means that for each of these regions of interest, we actually evaluated changes at the building level. In this way, we were able to identify basically the structures, specific structures that experience the high, like a level of change between the pre and the post-earthquake. And these structures that we see here, for example, were classified according to two classes of interest based on the difference in the number of monitoring points, PS points, between the pre and the post-earthquake. And for example, for the buildings that we see as yellow, we found a moderate difference in PS points between the pre and the post-earthquake, while the buildings that are represented as red were buildings for which we observed a large decrease of PS points between pre and post. We actually, of course, had some buildings that didn't experience much change that we could assess, we could define as green, and here have not been represented because they're less relevant for our purpose. For the purpose of the field investigation, we actually decided to focus only on the red buildings, on the buildings that experience a large level of change. And since for each of these buildings, we actually possess the geolocation information, we were able to import the coordinates of each of these structures into Google Maps on our phone. In this way, we were able to use our mobile device directly in the field to go after the specific buildings and understand what happened to the building. So once in the field, we wanted mainly to reply to two questions. First of all, we wanted to understand whether the output of the remote sensing analysis was matching what we were able to observe. So if the red buildings were actually buildings that were damaged because of the earthquake. And in the case of positive correlation, so if this was actually verified, we were recording the information in the form of a picture. Then the second question was actually evaluate whether we, in case of buildings for which we were finding positive correlation, we wanted to basically evaluate what happened, what was the current condition of the building in order to evaluate the progress of reconstruction using this kind of information. So here we have some preliminary results following our field investigation. And on the map on the left-hand side, we see the distribution of the red buildings for one of the three investigated areas. And in the map on the right, we have the distribution of the pictures that we collected during the investigation. And it's here important to highlight that the three areas highlighted in black are actually regions that we didn't have time, that we didn't have opportunity to visit during the investigation. What we can see is that overall, the correlation between the results of the remote sensing analysis and of the field investigation is good, meaning that for most of the red buildings, we were able to find a positive correlation with the observation in the field. Then, since we were also interested to use this information to evaluate the progress of reconstruction, we basically, for each of the red buildings for which we found a positive correlation was classified according to the current condition of the building. So for example, here we have a bunch of red buildings for which that we found to be demolished and not yet reconstructed. Here we have examples of buildings, red buildings showing a positive correlation in the field that we found as being under construction. And here we have examples of red buildings that were already being reconstructed since the 2015 earthquake. In conclusion, we have seen that remote sensing tool can support field investigations during the recovery phase following major disaster. We've presented a method that is able to highlight, that is able to use remote sensing tools to highlight areas with high concentration of damage and identify specific buildings that were most likely affected because of the earthquake. We have shown how this tool could be used to guide field investigation either immediately after major disaster to locate damage or to be used during the recovery phase, like in this mission, to track, to assess the progress of reconstruction. And finally, we've shown a positive correlation between the results of the remote sensing analysis and what we observe in the field. So thanks for listening, and I'm going to hand over to Rohit, who's going to introduce the building structures.
Good afternoon, good evening. I'm Rohit. Now the presentation will focus on building structures, and we will cover two types of buildings: the residential housing and then the schools. So this is just a snapshot of what was the damage and impact to the residential housing. In the last 2015 earthquake, almost 500,000 houses were destroyed, and another 250,000 were partially damaged. Although both RC and masonry houses were affected, the masonry typologies were hit hard because of the poor construction practice or inherent poor capacity of those buildings. On the other hand, more than 7,000 school facilities were affected. Luckily, it was a Saturday, so no children were present there. Directly or indirectly, 1 million children were affected. Estimated cost of education sector damage and recovery was about 415 million. The immediate impact was school closure for several months, and the long-term impacts or indirect impacts were psychological effects. For example, lack of enough classrooms, use of makeshift temporary facilities, poor wash facilities that continued for years after the earthquake. And we can even notice in 2022. In terms of reconstruction and recovery, about 80 to 90% of both private housing and school sector has completed, according to the NRA data. So I will talk briefly about the funding and recovery reconstruction mechanism. So based on the post-disaster needs assessment, NRA was established in 2015, which was provided financial assistance from the international aid and international governments. So, and there were three different CLPIU, that is Central Level Project Implementation Working Units, one on the grant management and local infrastructure side, one on the private housing building side, and one for the schools. So for the private housing, it was owner-driven reconstruction. Owner was the main player for the reconstruction, and the government supported about $3,000 US for the reconstruction. And for the technical assistance, trainings and facilitation was provided from the National Reconstruction Authority. For both schools and buildings, at the private houses, these were constructed following the up-to-date codes. For the schools specifically, there were sub-projects, for example, funded by ADB or JICA or USAID that supported the reconstruction and recovery. And for the schools, it was a chance to upgrade the facility in the schools as well. So I will first talk about the seismic design change, the major codal changes in Nepal about the seismic design. So the initial code was 1994, and recently it has been revised in 2020. You can see in terms of hazard, the maximum PGA range is now changed. It has increased, which gives more safety to the designed buildings. Performance limits were not defined in the previous update. It was not performance-based code, but in the new code, there are two performance levels introduced. You can see this design spectrum. In the previous code, there were 3 different soil types only, but in the new code, there is a 4th one, which is soft soil, which represents the Kathmandu Valley. And if you notice the period range is longer for the soft soil type. It is up to about 2 seconds. That means the most of the residential buildings are designed in that period range. So they will be now designed with higher acceleration level. In terms of the reinforced concrete seismic design, there is a significant improvement, as you can notice. In the 1994 code, there were, for the columns, there were only columns of 9 inch by 9 inch, which was small column cross-section size that caused collapse of many reinforced concrete buildings in the 2015 event. And furthermore, the reinforcement bars, as you can see, there were only 4 rebars needed at 4 corners, and the shear ties were single ties and poorly distributed. Similarly, the joints were not seismically detailed, ductile detailed. Now in the recently revised code, you can notice the column size minimum is 12 by 12 inch. There are double shear ties, which provides better ductility. Similarly, the longitudinal reinforcement amount has increased, and joints are better detailed now. In terms of the progress in seismic design practice in the country, for example, there is good progress, I would say, because these are the design catalog of buildings, different material types, different construction technology, but all are designed according to the new design codes. So they are code conforming, and the house owners have to choose one of these different typologies in their construction to make their buildings safer. Also, in terms of dissemination of technical information and knowledge, materials were produced in Nepali language to efficiently disseminate the knowledge and information. There were radio programs, local radio programs, and national as well. And there was even a TV program where the experts would come and talk about how to build safely. And there were more than 70,000 masons and carpenters trained, which was better for economy as well. I will focus now the presentation on schools. We visited about 11 schools, and you can see we visited urban schools in Kathmandu Valley, 2 semi-urban schools were located a bit far from the valley, but still on the national highways. And we also visited some remote locations. In terms of the construction types of the schools, so before the earthquake, as you can see, there was most of the schools were of masonry typology. However, after the earthquake, the majority of construction type is reinforced concrete now. Okay, finally, now, so before the earthquake, as you can see, there are no seismic bands. There are no lintel bands. Even in reinforced concrete buildings, the columns are poor in size as well as poorly reinforced. That caused the damage of these buildings in the 2015 earthquake. However, in the reconstructed buildings, these follow the seismic design codes and are seismic resistant. So here the question is, NRA and the reconstruction and recovery framework had one objective of including the sustainability in their reconstruction. So use of local materials, use of local knowledge and workmanship, and sustainability. So if you compare the before and after scenario, most of the schools are constructed with reinforced concrete. So there is no use of local materials. For example, the masonry, the stone, or the mud, or timber. So knowledge had to be transported from city to remote locations, because local masons were either have to be trained or have to be imported from outside, because the local carpenters and masons were not very useful in this construction type. And there is a question of sustainability. The reconstruction quality. So the quality of newly built schools is very good. The workmanship is also good. It follows the seismic design codes, the concrete bands in the masonry walls, the reinforcement as per the design code, joints are well detailed. So construction quality is very good. There were some issues seen in the reconstructed facilities, but these are very localized and not so common. For example, there is forming risk in this situation. The building is built on a slope, uneven surface, so there is chance of landslide or So there are some foreign non-structural hazards which could be corrected, but these are very localized and not common. And on the retrofit side, there is a lot of retrofit ongoing on the schools. For example, on both masonry and reinforced concrete. So on the masonry schools, they follow this bandage technique. They call it beams and columns, but only on the outer layers on both sides. And also in the infill walls of reinforced concrete buildings, same style. And they follow the column jacketing for the column strengthening. This is the same for even for residential buildings retrofit, but the retrofit on residential building side is not going so well. I don't know the reasons for delays, but that has not gone well. So this picture shows before and after photo of the. So this is 2015 scenario. There are some damages, even if you cannot notice, but this is already poor in construction. So poor column sizes, poor reinforcement, and this is 2022 scenario where the retrofit work is ongoing. In summary, the retrofit work out of 11 schools we visited, more than half of the schools had some of the retrofitting activities ongoing in some buildings. So I will give you an example. For example, in one single project funded by the ADB, they were retrofitting about 140 school facilities. That's a huge number for one single project, and there were other projects which were carrying out the retrofit activities. So in terms of sustainability, so this retrofit activity has contributed towards the sustainability agenda with this. So in terms of the facilities, before the earthquake, there were poor or not enough wash facilities, for example, toilets and bathrooms, but after the earthquake, the toilets are built earthquake resistant, as you can see, and there are enough number of toilets now, at least in those visited schools. There are drinking water and wash basin facilities almost in every school, and there is internet connectivity in each of those schools we visited. Even in remote locations, there is audio-visual rooms, there are computer facilities for children, there are libraries, there are science labs, and so on. So the disaster was a chance to upgrade the facilities for those schools. I will now hand over to Son. Thank you.
Okay, thanks very much. I'll try and be quick. So I'm going to be talking about residential buildings and how they've been either repaired or rebuilt. So if you were to go to Nepal before the earthquake, and even now, you'd see a lot of buildings like this. So typically they're reinforced concrete frames with masonry infill, for the higher quality buildings, and masonry with wooden frames and wooden floors, you'll see those, and then you get rubble filled masonry with either lime or mud mortar. So these are some pictures from the 2015 earthquake. Good. So we can see, we can take this one down the bottom here. It's got wooden floors held up by wooden columns with masonry on the top. Enough about that one. Similar here, this one is another masonry building with timber floors, and you see the whole front coming off. And then you can see a lot of still standing, but also collapsed reinforced concrete masonry with masonry infill, and that's sort of the primary bigger and taller structures that we would see. And that was sort of the typical damage patterns that we saw in 2015. So if we I've just two slides on what we found when we went there. So this is in Bhaktapur, near the temples there, and we can see, this is one example, this is the same building, so this bit here is here, and we can see reinforced concrete, columns and beams, as Rohit said, 300mm columns. We can see bands running through, top and bottom through here, and concrete slab, and then the masonry going on the outside. So that's a typical sort of building that you might see. Here's a couple more from the same area. So here, this is probably a better, nice example of newly built building. So this is a concrete slab. If you look in, you can see concrete beams, and you can see sort of the masonry cladding on the outside, sort of non-structural infill wall. Now, this one here is in Gorkha, so near where the epicentre was, and we still see some bad planning there. So this one was reported to have had this story put on after the earthquake. Okay, so you've still got the original, even though you see some bands there, which are a bit strange, they just go between two columns. So we're still seeing some planning issues that are happening, and this is in a more remote region, not near Kathmandu. But as I say, and if you look back to some of the pictures that Rohit showed, I haven't got many showing ones in construction because most have been built, but you could see the ones that were being constructed had a lot more reinforcement, that same sort of reinforcement that we were seeing in the school. So it looks like building back better is going quite well for residential. Now, as often in an earthquake, it was no different in Kathmandu, in Nepal. The more remote a region is, the bigger the impacts and disproportionately affected by earthquakes. So in 2015, we went to a number of villages which were inaccessible by road, so it was very remote. This is Lapsabot. When we went there, they were typically rubble masonry with mud mortar. The villages that we went to, every building was damaged, with many collapsed. So that's the sort of thing that we saw. Now, we couldn't go back to that village, those villages, they were a bit, but we did go to one that's 11 kilometres as the crow flies, and to get there, you have to go up one of these scary roads that you see on YouTube all the time. Well, that's what it felt like to me. The drivers seemed fine with it. And so this one's called Barpat, and we can see the typical construction there. Now, it was reported to us that they got the $3,000 that Rohit was talking about, but also they get remittances from Gurkhas. So Gurkhas are employed by the British Army and the Indian Army and the Singapore Police Force. They send money back to their villages, and this was reported as being sort of the major income. So this might be, or is an example, probably a village that's possibly wealthier than other villages. But again, this was reported that there was only one original building from 2015 still standing. And as you can see, reinforced concrete, lovely band beams. And the only potential issue, I'm not saying it is an issue, but these masonry in here. So because this is on a seasonal road, masonry tends to get damaged as it's being delivered on these really uneven roads. So they've sort of solved this by actually cutting marble or some very dense, very strong, very heavy brick that's cut by hand. Some of them are masonry, and then they put this cladding, a thin veneer of this marble on the outside. So they look fantastic. You can see they're all like that, and they're all reinforced concrete with reinforced band beams. So whereas usually you go out into the countryside and these people are disproportionately affected, we've seen that this village has recovered very, very well. There are a few issues though. Get my notes, make sure I don't forget anything. And that is, so two things. One, they reported that they got a lot of help from external engineers funded by the Japanese, that they were on site for 3 years and they were travelling around the different villages helping the upskilling the masons and the other builders there. And the only negative thing was it was reported that they didn't like the buildings, they liked the earthquake safety of them, but because they were made out of thin walls, they were too hot in summer and too cold in winter. So maybe a little bit more communication as to what makes a good building from a comfort point of view. I think that's all I want to say. Yep. So I'll now hand over to Paul to talk about. Oh, sorry.
Awesome, thanks. All right, I'll take it. So yeah, I'm going to finish off. I'll talk a little bit about heritage, and and then I'll just finish off with our general conclusions. Not too much to say about heritage construction, really. I think that, as with most other parts of the world, heritage buildings generally take longer. There's a bit more effort and thought goes into their reconstruction generally. I think just two examples here. The Daha Tower, it was a mud brick tower, you can see it there on the, that's how it works, on the left there. It was a mud brick tower, collapsed in the earthquake, and then was reconstructed in reinforced concrete. There's different ways of doing heritage reconstruction, or different ways of doing reconstruction anywhere, but you know, it depends what's the aim of the game, basically. Here, we're reconstructing the same tower in reinforced concrete. The alternative to that is rebuilding with traditional techniques. You say also similar techniques. So just an example there of rebuilding in brick and putting the roof on there in timber. So that's a quick, easy note. Just a comment, I suppose, really. There's the same building 7 years down the line. I know that the propping went in pretty soon after the 2015 earthquakes, and it's still there. There are ongoing discussions about how best to fix these buildings. I think that's the simple answer, and you know, will get done, but heritage buildings take time, there's lots of stakeholders. Clicker's not the best, is it? I don't know if anyone picked it up. I'm Paul, I'm from the north of England, but I live in New Zealand now, and I've been heavily involved with Christchurch rebuild there, where we had earthquakes in 2011, and so it was interesting for me to be involved in the Christchurch rebuild and look where we were 5 years down the line and then 7 years down the line. And I managed to pull this graph from the Christchurch City Council websites. There's what was planned, there's what was planned on a graph, and then some projects got cancelled, some hit their deadlines, some extended their deadlines. The main one here is Christchurch Cathedral, large religious building in the middle of the city. 5 years after the earthquake was still looking like that. 7 years after the earthquake, still looking like that. 10 years after the earthquake, still looking like that. But now we've got a plan for how it's going to get built. And I feel, I've talked to a lot of people in New Zealand about this. I feel that Kathmandu is in a similar situation to Christchurch, really. That we've done quite a lot of the residential fixing 5 years after the event. I mean, that's Christchurch maybe a year ago. There's still some cranes, there's still construction work going on. Most of the residential stuff's finished. The commercial, the centre of town is getting there, and the heritage buildings are the last to come along. So I think that's a reasonable learning that can be taken from both of these. And I'll just keep clicking. So our conclusions from the structural engineering, which I think are not exactly what we expected when we went, but let's, you know, I'll explain what we've got. Build Back Better. That was one of the intents of the mission, to see if that was happening. I would say wholeheartedly the buildings which are being built back are better. Design codes, the Nepal design codes were updated just before the earthquakes happened, but are now being wholeheartedly followed, is probably the best way to describe that, as opposed to minimum sizing, so that's getting there. Schools were perhaps disproportionately affected by this earthquake and then by the reconstruction and retrofitting, and the quality of construction in schools is top notch, really. I think that's fair. So good for schools. The workforce has improved. There are some seismic vulnerabilities, there always are. What we found interesting is, as a result of the various factors, reconstruction is generally prioritised over retrofit. So really, people are rebuilding, fully reconstructing rather than retrofitting, and I can understand the drivers for that, really monetary and personal. Really, it was easier to get a new house than retrofit sometimes. You know, retrofit is difficult. again, the finances, the donor money coupled with donor expertise is good, coming in, bringing both expertise and money, builds the economy, builds the expertise there. The bar pack that we visited was very good, so that was fully rebuilt, but perhaps more consultation with residents might have led to a slight improvement on the housing. And so, are we on to key messages there? The key messages we've got: significant progress, we are building back, the seismic hazard mapping and understanding is improving, or is improved, certainly, and is a continuum, always will continue to be improved. Tweets were generally by NGOs and foreigners, I think, really, it's fair to say. I think that changes with every passing year. Social media, just, there's more and more penetration of it, really. Participatory methodologies provide insights, so we were able to match up the methodologies with the remote observation. Remote sensing, I think it feels like it was working, the system's working. I was really surprised by the level of detail these guys get to this. It's really good. So they were useful for guiding field responses. And I think we're going to finish on structural engineering. I'll just move that slide to there. But sustainability, I think, was something that's close to my heart, was a few of the team members' hearts. I think what we would say, and then Rohit, showed it in some of his slides, that the retrofit is good. That's a sustainable solution. The seismic resilience has definitely improved. The amount of money and thought that's gone into schools has meant we've got better, toilet facilities, we've got better IT infrastructure. The general sustainability message is, is going there. But you could argue that the thermal performance of buildings, the heating, cooling, wasn't, particularly thought about in the seismic retrofit designs. Material consumption wasn't prioritised. That was what we thought. We held a workshop in the middle of the mission. The thoughts coming out from that, from the engineers that I talked to and the team talked to, there was a lot of concrete being used. That's, it's obviously, we've increased the column size for the standard design, the amount of concrete has therefore gone up. Construction waste is an issue, and again, it's suitability of the designs that are being used there. And so perhaps going forwards, that's something the ISTRUCT EEFIT needs to be thinking about in terms of what we do with earthquake reconstruction. And I think that's it. Thank you very much. Does anyone have any questions for the team? We've got 5 minutes. We've got 7 minutes.
You can take him on.
How long will it take for the analysis to be happening before and after? Let's say an earthquake happens now. How long after can we see that we have recognized damage?
Yeah, it really depends. So we are getting better and better even because the availability of data is getting better. So right now, what we have done is clearly not indicative of an immediately after. It was more than 7 years after. So it's analysis that we had all the time in the world. But ideally, this kind of analysis, right now we could do it after a few weeks, because they require, you saw, I don't know, from this side of one of the pictures, multiple numbers of images, but satellites are getting better in the acquisition itself, so the revisit time is shorter and shorter. So we are probably expecting in the future to have the same amount of information in a week, as opposite to few weeks. This is not the, let's say, the fastest methodology. So we have satellite information that comes 2 hours after the event, and we can make analysis, different kind of analysis based on that. Optical satellite is used for the emergency purpose in this situation. In this case, we were sort of looking also at the reconstruction part, and so we used some more sophisticated tools in the displacement reconnection because we could afford, let's say, the time, or we are designing for situation where time is not necessarily an issue. So it depends on the satellite, sorry. Yes. Yeah.
How do you realize that is the layout of the building? Are you putting Google map on top of the
Yeah. I think probably, I think it will be very satisfactory for Matab to reply to that because a lot of work has been put on that specific task.
Okay, and the footprint that you saw was from OpenStreetMap, that we extracted the building from the OpenStreetMap, and we just counted the significant scatter points identified as the time state analysis from before and after the year, and just count the difference.
The density of the building increases, you're not worried about everything either. So lots of things being all together, math,
I didn't get your question. I don't know.
Let's say you have an area which has plenty of buildings, and you still think that you can recognize the building layouts correctly without any error?
I can add something in that because I know it's difficult to summarize a long discussion that we had. Is no, it's not, and that's why we also use the grid system because for OpenStreetMap it's not as good. It's not good as everywhere. Like in the same places, we don't have the same accuracy. So. For the large buildings that they are fairly isolated, it's a sort of a luxury to be able to detect that. But for the situation that you are mentioning, we have alternative way. For example, using the grid, the 100 by meters grid that you have seen can be made, neighborhood level or few buildings level, and still we will get the areas where damage is more or less intense or changes are more or less intense. So it will equally work even if we don't manage to point at the specific building as a guiding tool.
My question is a bit less strategic in terms of remote sensing and detection tools. Your opinion, would satellites be competitive to exotic drones, radar mounted drones, be quite good for the recovery
So it's really not the same. We don't have. We have used for previous missions also comparison for the IT mission as well. Comparison between drone satellite data and LiDAR data where possible. LiDAR is no, it's not. It's not the same level of accuracy. Especially if you're thinking optical satellite, it's not the same as having an image that is acquired by a drone. Or if you think in terms of displacement, it's not the same as the type of deformation that you can get from LiDAR. However, you don't always get that. So not in every event you have, it can be the university that gets funding to do the immediate search afterwards, or it can be that there are infrastructure in place, but not in every place that information is available. So we are trying as much as possible to develop tools that they are flexible to the use of different type of data. So if you are in a good situation, you have the more accurate, let's say, higher quality of data, fine. If not, this also works. Second point is that with all the tools that you mentioned, you usually get, majority of the cases, you get only post-event information. So something happened, you send dedicated tools. With satellite data, you can go to the archive, you can go backwards. So the change detection is sometimes easier in a way, or more doable because of that.
question. So you mentioned a bit changes that we do from the actual to the so, any idea of what is the participation? What we need from reconstructing more in art, therefore the art quality, consider some of the options. What are your
So, in the earthquake, most of the buildings that were damaged were of RC so the masonry typology. But the reason was they were poorly built. If they were built seismic resistant, like confined masonry or reinforced masonry, they would be standing. But that knowledge gap resulted in people thinking that RC is the construction type we should be following because these are safer. So that was the general community concept, and the improvement of masonry typologies, I think it takes time. So there was no time to do that and then implement in schools. So the fastest and safest way was to go with the RC construction types. And one single building of RC type would give you 4 classrooms, 8 classrooms, 16 classrooms. With masonry buildings, you would need 4 or 5 buildings for equivalent number of classrooms. So that was the main driver, I think. And there were no discussions of sustainability or use of local materials at the country level or at the management level. Although they included some clauses in the recovery framework, but that was not discussed and realized in the real scenario.
Does the work works on the basics or as well as the ground surface conditions? I'm from Nepal and I've seen a lot of it. So I've seen that some of the entry lands are highly affected by the during that period. After the earthquake, the new constructions were again being underground. So does the remodeling of the activity on the road?
Anything you want to address, sir?
No, I would say that the year from the object from the location of the building.
Yes, exactly.
But it works on the ground surface conditions.
Right. So usually the building is built harder because of the shape of the material, so it's something that is very well related. Like the ground surface usually doesn't, so it's something that you can't really have very clear cycle. So you can't really detect the ground. What you can detect sometimes a lot. So, but in case of the utility areas, for example, or even the pavement of the street, it's something that usually doesn't affect the light. For example, in the roadway or to the left, is usually the side of the roadway structure. So it's less reflective and uses less point. The road is well on the building, but less well on the ground.
In terms of accuracy, it's not that kind of accurate. For example, the ground surface conditions in some of the parts, like some of the parts of the Kathmandu area, and some of the flats, they are highly affected by the ground.
Yes, but we were really interested, like, not like assessing every aspect of the earthquake, but here the project was very specific on the building. So that, there are like different tools, different ways that you can apply to that. Each piece of work is really very good.
I have one other question. I think in the first two slides, I feel that Mike has shown some of the upcoming estimation of the earthquake, like in the southern part of the Nepal. I'm pretty sure there are very good earthquake.
That was the magnitude.
Yes, so it's a magnitude, yeah.
I know the PGA.
So actually, I'm concerned about those things. Like southern part of Nepal, there are still some design parameters that are 4 years outdoor individual based standard. So these parameters will be more concerned for the post-disaster status. For example, they are still building in the then code based on the Indian standard for the community. So that parameters depend. I can say that, for example, the national level projects, they cannot be changed, the design rules cannot be changed for this one. But the funded project, so then they will be concerned about the design parameters as the money of the line.
So I think you can probably answer better for the code, because the code was updated in 2020 with new parameters for the assessment of the PGA and the time series history. So they should be building that updated code from 2020, which should take into account the more detailed level of understanding. But the magnitude frequency relationship and the peak balance correlation is not quite the same as the magnitude airflow. They're not quite synonymous between the two. So the PGA, which comes from the code, is different to the mode of magnitude from the airflow. Because it's doing some geology and geotechnics.
Yeah, I
You don't just about
no, I did not find my voice. Sorry, guys. It's just a question I think probably Mike combine. One of the slides showed a rebuilt house on a site that was potentially a landslide potential. So one of the things I just wanted to ask is, although they've updated the building site design criteria, has there been any consideration of actually planning issues around allowing people to build buildings on potentially sites that have secondary
So I can answer this one from 2 points. I think it also picks up the question about reclaimed land and build. I don't think the microphone but so they are having things on where they've got do not build houses and design gardens on slope angles. And they are doing sort of hazard mapping for land types, still a work in progress. And looking at the secondary mapping, looking at the factors that impact that. So there is actually a problem with infill and building on slopes that are still really unsuitable.
Yeah.
We visited some areas where they're basically building out fill out on the slopes that have no real probably detailed design, and then building foundations on that. So the actual link between geology and geotechnics, and then the building is not really fully in the value. I think there's a lot of cascading hazards that hasn't been fed into the disaster of this production. I think we probably have to call it time, because I think we've been allowed to stay a few minutes late already. But you can continue outside in the rain. Find a pub.